In order to understand action potentials, we have to start by understanding voltage-gated channels. So here's a voltage-gated sodium channel. This is a schematic. The actual channel structure is a little different from this, but this is a good way to think about it. We have an activation gate and an inactivation gate. The activation gate will open the channel. The inactivation gate will close it. Okay. So what's going to open it? Well, remember that the inside of the cell at rest is around 70 millivolts. This would be true for any cell, including a neuron. And if this region here, if there's a hinge right there under tension, then what we have is a negative charge on the inside attracting that positive region of the activation gate. So at minus 70 millivolts, that gate is held closed. Well, what happens if we make that a little more positive? So if something else, and we'll talk about that something else in a bit, if something else brings some positive charge into the cell, that positive charge, as it gets close to this area, and if it changes our minus 70 to somewhere around minus 45, so if we get to somewhere around minus 45, that's enough positive charge that it now no longer attracts this gate so strongly, and that gate pops open. Okay, so the gate pops open, and once the gate pops open, the inside of this cell is now around minus 45. We have a high concentration of sodium on the outside, and remember the equilibrium for sodium is plus 50. In other words, sodium would enter the cell until the inside gets to plus 50 instead of minus 45. So the effect of that is to bring sodium into a cell. That would continue and could continue until the membrane potential reached about plus 50, except remember that going on in the background, there are always some potassium leak channels open. So we don't quite get to plus 50. We get to around plus 30, and at that point, at plus 30 millivolts, the amount of sodium coming in, is balanced by the number of potassiums going out, because we have those two types of channels open, and so we get to about plus 30 millivolts. That's the first half of an action potential.